So, one of the bigger overarching concerns, as Tyler, I think, already has mentioned, is figuring out the quality that we need, right, for our plasmids, and understanding what metrics for that quality need to be to create high quality mRNA compared to another type of product. So, that kind of brings me to thinking a little bit about some of the analytical limitations that we're facing as we're trying to understand our plasmids. And so I have a question sort of to address to the full panel, and maybe Adi, we can start with you and then go through April and Tyler. But, what's missing from our current analytical toolbox, specifically for better understanding the plasmid quality for mRNA production? What do you think?
Yeah. So one of the most important metric that is used to understand plasmid quality would be the topology itself of the template that we get, right? So there is a lot of interest in the percentage supercoiled nature of the plasmid itself. Before it's linearized, right? So how important it is. And they say that there is a direct correlation between that particular metric and the quality of RNA that you get after IVT. So that's there, that's definitely there. And then there are literature citing, okay, it's definitely relevant. And then there are literature citings which says, okay, maybe it's still not clear yet. So how do we go about figuring this out? So, and in almost all of those things, they have mentioned the use of capillary electrophoresis for a better understanding of how good this product is. Because we need to understand that from a plasmid fermentation point of view, how do I put this? The supercoiled nature of the plasmid is a critical quality attribute, if you will, right? From a quality by design point of view. And by the time it reaches the IVT stage, it becomes a critical material attribute of the template itself. Now, how do we analyze this? And what are the process parameters that are exactly affecting this particular quality attribute of the template, right? So some of this I've seen mostly focused on the capillary electrophoresis side. The problem is it's not real time. So if you have to integrate it within your manufacturing process, you might have to wait a bit to rectify any sort of problem that you are facing during the manufacturing process or during the downstream processes, right? So that's there. I see some newer techniques being tried out, but I don't know where they are. It's still maturing, right? So and they are still figuring out what are these specific problems associated with the plasmid DNA that translates into a poorer quality in the mRNA. Is your plasmid DNA nicked? If it is nicked, how does that affect the overall process? And as far as your capillary electrophoresis, definitely. Just to sum this up, the other thing that I've noticed was next generation sequencing. So because NGS has a big role to play in this, if you can figure out if the template is nicked at some point, that can help you kind of rectify your process parameters that is causing that particular damage. So these are the two things that I think need to be improved and can be implemented within the manufacturing space, right?
Yeah, there's a lot of density here too. I mean, I was just attending the USP quality event yesterday and the day before, right, on all of the different analytical techniques we're using to understand our mRNA LNPs. And, we're going through a lot of exploration, and even just trying to figure out how to make these different methods reproducible. So doing that on the plasmid side is its own, topic of discussion, right? I feel like there could be a whole day spent, just day or two event focused on quality of the plasmid, right? And some of the analytical tools we need to understand that. Tyler, I know I saw you nodding throughout Adi's explanation. Are you in firm agreement?
Yeah, I am. And I think there's definitely, trying to parse out and use NGS versus capillary electrophoresis to truly understand, is it supercoiled that we necessarily need, or what is the free open circular forms? How percent of that is nicked? What are those different, attributes within that population of DNA? Because at the end of the day, we're going to linearize all this DNA. The supercoiled is now not going to be supercoiled.
Supercoiled.
So, I think if it's a perfect open circular, and it's linearized, it likely should work well. The question is how much of that is truly still of itself, how much is nicked, where's there maybe some sequence changes or things of that nature. So I think NGS absolutely is going to have to play a role in us understanding our individual products.
Yeah.
But I do think tracking supercoiled will give you an idea of, well, how well did the fermentation and the plasmid process go?
Okay.
You know, those types of things. I think it doesn't seem like more supercoiled is bad, right? I think that's
yeah.
the
It gives
answer
you
here.
a sense of the quality of the production process at least, so you know the quality of the plasmid is probably high, right?
Yeah.
Okay.
But we do need more resolution, I think, on that side with NGS and others. And so I think a lot of people are focused on that.
Yeah. Yeah. April, would you agree? What are you watching? Yeah. I see her nodding.
Sorry, I had to find my mute button. Yeah, absolutely. And I think,
well, she's nodding.
yeah, I'm nodding. And I also think these things are going to become even more important when it comes to larger and larger plasmids. So if you look at the vaccine industry, they're looking at potentially self-amplifying plasmid, or using some of the alpha virus genes to self-amplify the mRNA to get a more robust and a longer lasting immune response. Those plasmids are a lot bigger. So these concerns around the nicking and, it becomes really important because there's more things there to be nicked. And it's a huge problem, I think, when you're making the bigger plasmids. So.